Hello and welcome back to another video, and in this video I'm going to show you this 125 plus 125 watt power supply. So let's get started. So first thing first, let's power up the power supply. So we have two I2C 20x4 liquid crystal display. We have rotary encoder for this display for adjusting menus and settings, which I will show you later on. And we have this voltage and current adjusting knobs, and again we have this rotary encoder for this display and voltage and current adjusting knobs over here. Also we have the output that we can take from here, and that's all we have in the front. And let's see what's on the back side. So on the back we have this main power input, and that's all we have on the back side. Now let's see the function of the rotary encoder. We have two rotary encoder, they are functioning the same. We have two individual power supply inside, so that we can also series these two to get more output, and we can also parallel. So let's see the function of the rotary encoder of this one only, because both are same. So first I'll show you how to get into the calibration menu. So for that you have to power it on and then quickly press the rotary encoder switch, and then it will go into the calibration menu. So in the calibration menu we have some calibration minimum and maximum settings that you can adjust. So for calibrating you have to put the voltage adjustment knob to the minimum, and check with the multimeter if the minimum is same, and if not you can adjust this value using the rotary encoder. You can press, and when it is selected it will show cross sign, and then you can adjust the value. And also while adjusting you will have a click sound, because I have also implemented a buzzer. And to check the maximum you have to put the knob to the maximum, and then check with the multimeter, and if the voltage is not same you can adjust the max value. And for the current it is same, you have to just put a load and check with the multimeter for the minimum and the maximum value. For then after doing that you can exit or save. So I will just save it. So after saving it will beep. We have this continuous setting and we have this one shot setting. So what are these? So I will quickly describe with the load. Let me just grab a load. Before I show you the continuous and one shot mode, let me just quickly tell you what's on the screen. So we have the actual voltage. CV means it's in constant voltage mode, and off, the state of the output is currently off, so it's saying off. When it's on it will say active. And we have the actual power and the actual current and the mode over here. So in continuous mode what it does is it will keep the output remain on no matter if it is in constant voltage or in constant current. So let me quickly demonstrate that. So first we'll set the current. For setting the current we have to shorten the output, and I have set it to about 1 ampere, and now I will try to get more than 1 ampere. As you can see it is limiting me from going more than 1 ampere. It will go less than 1 ampere, but it will never let me go above 1 ampere. So I can go above 1 ampere by adjusting the current. Now as you can see I am getting more than 1 ampere. So that's that. And now if I go from the continuous mode to one shot mode by rotating the encoder, it will shut off the output. So now we are in one shot mode, and I will disconnect the output. So the load is disconnected now, and I will switch on the output. And now as soon as it will hit the constant current, it will shut off the output. As you can see, now it's saying it's protected. So that's a safety feature that you can use while testing circuit boards. So let me just turn on the output again and show you again. So I hope you understand what's the functionality is. So both the channels has same function, and now let's see how accurate the readings are. I have connected a multimeter to the output of the first channel, and let's switch on the output. So I have switched on the output and you can see the active written over here, and we have voltage output of 7.392 and exactly we have 7.39. So let's go down a bit. Let's try 3.3 volt. And we have 3.308 and we have 3.309, and let's try 12 volt. So it's 12.04 and we have 12.04 on the output as well. So it's pretty accurate. And now let's try the current as well. So I have set the multimeter and let's try the current reading as well. So as you can see, the current is also pretty close. I would say you can also tweak this in the calibration menu, but it is currently good enough. And let's try little bit more voltage so that we can also get little bit more current. So the slight error can be adjusted in the calibration menu, but for now let's see the inside of this power supply. First we have the main powers coming from here and the main power switch. We have two power supplies because this is completely identical but completely separate power supplies for the two channels. We have same things for the channel 1 and same for the channel 2 as well. So I will just mention for channel 1 because channel 2 is obviously same. So for that we have a small buzzer, the Arduino Pro Mini. We have a small buck converter, 5-volt buck converter for the Arduino. We have the main buck converter here which is responsible for the output. Then we have this ADC which you can see on the screen right now. We have some 10-turn potentiometer for the voltage and Rotary encoder for the menus. We have this I2C display. Then we have this voltage and ampere meter which you can see on the screen right now. I am using this for its shunt and its voltage divider only. I am not using anything else on that. And then we have the output controlling circuit over here. It consists of relays, and that's all from the inside. If anybody wants a circuit and code, they can comment it down. I have not posted it yet because I don't know if somebody is interested in this or not. So let me know in the comments below, and if you like this video then don't forget to hit the like button. Also subscribe before leaving this video, that will motivate me. That's all for today. I will wrap up this video now. Bye bye.